Hello everyone. So in this video we will learn how to use conditional parameter in COMSOL Multiphysics. This is a very important feature in the software which many of us did not know, and if you are working with advanced simulation where you need to add conditional statement, then this is very useful. So let me just give you an example of how this can be useful to you. For example, let's say you have a container and you are providing some kind of a temperature here, and let's say you need to turn on a switch or a parameter at the top, right? And the condition is that if the temperature is greater than 300, only then the switch will turn on, otherwise the switch will turn off. Or let's say there is a current flow through a wire and you want to limit the flow of the current when the temperature is high, something like that. In that case also you need to add a condition. So for example, let's say current is flowing in this direction and the wire is getting heated due to Joule's heating, right? And you can add a condition that if temperature is less than 100 degrees Celsius, only then 1 ampere current will flow. If the temperature is greater than 100 degrees Celsius, then the current flow will be 0.5 ampere, something like that. So conditional statements are very useful in the software. So let us first learn about the if condition. Now if you have learned Java or maybe Python or any other programming language, you must have used if statement. So if statement works something like this: you write if, then you write the condition, then you have the command within the brackets, and then you have else, and then another section of code. So basically what happens is, if the first condition is satisfied, then this piece of code will run, and if the condition is wrong, then the second part will get executed. So let me explain you with an example. Let's say I have a parameter a and a is 5, and then I have, let's say, temperature, and temperature is, let's say, 300 Kelvin. Now we want to get a value of current. So let's say current we write as I, and this is 1 amp. Now we will write a conditional statement, something, let's say, if I is less than a, then temperature will be 200 Kelvin, else temperature will be 300 Kelvin. Now let me explain what will happen with this condition. So in this example we have I equal to 1 and a equal to 5. That means that this condition is satisfied, that is a is greater than I. In that case the value of temp will be 200 Kelvin. Now let's say I increase the current to 6. In that case the if condition is not true, so this will return a boolean expression of false, and then the second part will get executed. In that case the value of temp will be 300, right? So this is how the conditional statement actually works. Now we will learn how this works in the software, that is in COMSOL Multiphysics. So at first I'll just write a basic example, and then we'll move on to the software to check how this works. Let's say I have a parameter k and I write k equal to 2. Now we want to evaluate c. Okay, so what we will write in the software, we will write c equal to, the expression, if, we will open a bracket and then we will write the condition. So if k is less than 1, then print 0.5, take the value 0.5, else again if k is less than 2, print 1.5, otherwise 2.5. okay, and we'll close this and we'll close this bracket once again. So what is happening is that if the value of k is less than 1, so let me just write from 0 to 1, 0, 1, 2, 3. So if the value lies between 0 and 1, then the value of c will be 0.5. Then if the value of k is less than 2, that means in this range, it will give an output of 1.5. Otherwise, if the value is greater than 2, then it will give an output of 2.5. So you can see that this is a conditional statement. So depending on the value of k, the value of c will change, and the condition are evaluated from the left. So it will first check if k is less than 1, then it will execute this command, and so on. So now we will jump onto the software and see with few of the examples. So we are now in the software. So as we discussed in the example, let's write a parameter k and let's put a value, let's say 1. Now we will write the conditional statement here. So first we'll write c and we'll write if, open and close the first brackets, and then we'll write the condition. So we'll write if k is less than 1, then comma, then the value will be 0.5, else the value will be 10, right? And we'll click outside and you see the value is 10. Why? Because we gave the condition k less than 1, so this is false, right? Because k is 1, so this condition is false. So if the condition is false, then the second command will execute. That means if this is true, if k minus 1 is true, then it will run this piece of code, and if this is false, it will run this piece of code. For example, if I write k 0.9, then it will print 0.5. It will take the value 0.5. Otherwise, if it is wrong, then it will take the value which is second to the first value. So let's say I write here 0.8. you see that the value changes to 0.8. So this is the first step, and of course if I write here k 100, it will print 10. Why? Because for any value greater than equal to 1, the value of c will be 10, right? So this is the purpose of this command. You can always make this command as complicated as possible, as we discussed. So let us now write the code that we discussed in the example. So if k is less than 1, we'll print 0.5. We'll put a comma again, and then here we will write another condition. So we'll again open and close the bracket so that we don't miss the brackets. Here we will write if k is less than 2, comma, then print 1.5. We'll again put a comma, and we'll again write if k is less than 3, a comma again, then it will print 2.5. We'll put a comma again, and then 3.5, and we'll press a bracket and leave. Okay, so we have this statement. Don't get confused, I'll explain what is going on here. So let's say I want to write k0. Now at k0, k is less than 1 condition is valid, so 0 is less than 1, then it will print 0.5. okay, now let's say I write 1. So when k is 1, this condition is not valid, then it will execute this command. Now here this is a nested loop, so in this k is less than 2, this is true because k is 1, 1 is less than 2, then it will print 1.5. That's why we have 1.5 here. Similarly, if you write any value which is less than 2 but greater than equal to 1, it will print 1.5. So if I write 1.99, it will print 1.5, right? Similarly, any value which is greater than equal to 2 but less than 3, it will print 2.5. So if I write 2.01, it will print 2.5. And any value which is greater than equal to 3, it will print 3.5. So let's say I write 3, then it will print 3.5. Or simply here I can write k. I think this will work. So this conditional statement says that if k is greater than equal to 3, then k will be equal to c. So if I write 300, then c is 300. But if it is less than c, less than 3, so let's say k is 2.5, then c is 2.5. Oh, actually it's just matching with the condition, so let's say it is 2.1, then also it will be 2.5. So you can create as much condition as possible, and if you think that the expression is getting too complicated, you can divide the expression into smaller sections and perform your task. So this is how you write if condition. So let's write a as 2, b as 10, and we'll try to evaluate c using expression of nb. So now we'll learn a different kind of conditional statement based on boolean values. So let's say I want to calculate c which is dependent on the condition of a and b. For example, let's say I want to have a value of c that is a multiple of 100, but the condition is that this will only work when b is greater than a, and we have to add a multiplication sign here. So we have this expression. Now if you see that what is happening here, now b is 10, a is 2, that means this condition is true. If this is true, this will return a value of 1, and if this is false, it will return a value 0. Now b is greater than a, that's why c is 100 times 1, so we are getting a value of 100. Now if we change the value to 20, you see that the value of c is now 0. Why? Because b is not greater than a, that means this will return 0. So 100 times 0 is 0. So So this is how this works. This is really useful. So at first we will learn about the plus operation. So we write plus as the variable name. Now we will do the same example again, but now what we will do is we will write b plus a is greater than 20, and here we will write a star. Okay, so what is happening here is that now I have added a condition of the addition operator, that is, if the sum of two variables is greater than 20, then plus will assume a value of 100. Now let's say I make the value here 9, so 9 plus 10 is 19, then the plus is 0, right? Similarly you can do that with minus also. So we write b minus a. Now if b minus a, the difference between two variables is greater than 0, greater than 20, then we will have a value of plus. So if we write b to be, let's say 39 or 60, now you see we have a value of 100. Now you can imagine this to be two temperature difference, and depending on the temperature difference, if it is greater than some specified value, you can have some specified value of a parameter. That totally depends on the type of project you are working. Similarly, you can have multiplication and division as well. So I'm not showing that one by one. You can understand that well. For example, if I add a larger value, 7000 by 9, it will definitely be greater than 20, and this will hold. Okay, so these are the four operations: plus, minus, multiplication and division. Also you can use power. So if b to the power a is greater than 20, this will be valid. So for example, this is 2, and if this is 2, so 2 power 2 is 4. It is less than 20, that's why it is 0. So 2 power 4 is 16, that should also be 0. 2 power 5 is 32, that's why it is greater than 20, and the value is 100. So you got the point how this works. Now one interesting point that I want to mention, let's say I add again a plus sign here, or I just remove this expression and I write b equal to 20. Now what will happen is that it will check if this value is exactly equal to the specified value, it will return 1, otherwise this will be 0. So if b is exactly 20, only then it will return 1, otherwise it will be 0. So 100 times 1 is 100, right? So let's say if c is 200, and what we can do, instead of 100 we can write 200 here, and we have the value of c. Similarly, we can add not equal to. So not equal to is represented by exclamation equal to. So if the value of b is not equal to 20, then only this expression will throw a true value. So any number other than 20, for example, if this is 0.001, it will return 20, or any number, let's say 1, minus 100, in all other numbers it will return true. If b is 20, only then it will return 0. And then you have less than, equal to, less than, greater than. All these are quite obvious, but I'll just again show you the less than. So if b is less than equal to 20, then it will hold, otherwise it will not hold. These are like mathematical operation. So less than equal to, greater than equal to, less than equal to, all this. And now I will show different expression. So now a little bit of advanced condition. So this is a logical condition. So let's say I write C multiplied by, now what we have is, let's say we have two conditions. Now I want the value to be the value of C if B is greater than 100 as well as A is greater than 50. Then how we will solve? So we will write B greater than 100, and we have another condition, that is A greater than 50. You want these both expressions to hold true, only then it will return the value of C. What we need to do is we need to put a AND sign, that is 2 AND symbol, and this will work. So B greater than 100, so let's say B is 101, it is still 0. Why? Because A is less than 50. So if A is, let's say, 190, the value throws the positive value, right? So let's say this is final value. Yeah, similarly you can have any two condition. The AND symbol basically means that both the two condition should match, only then it will hold true. So if B is greater than 100, this is true, but A is, let's say, less than 50, that is, this is false. In that case this will not work, right? So both the condition needed to be true to hold this. Now we also have another logical operation, that is OR. So in that case we need to add vertical lines, that is 2 vertical lines. What this does is, if any of the expression is true, it will return the value. So if B is greater than 100 or A is greater than 50, if any one of the condition is true, it will return a positive value, that is 1. If both the condition is true, even then it will return a positive value. So if A is now 52 and B is 101, it returns C. But if A is 0, even then it will return C. If A is 51, B is 0, even then it will return C. But if both of them are false, then it will return 0. So these two conditions are useful here, and I also want to mention that there are predefined values in COMSOL that I think I should mention. For example, if you write G constant, this will return a constant value of gravitational constant, that is 9.8 meter per centimeter square, meter per second square. If you drag the mouse here, you can see that it's written G constant is a reserved name. To get the value, what you can do is just type G and you'll get the value here, right? Similarly, there are many other values as well. For example, the constant R. So underscore constant is quite common, and you just change this. So instead of R, for speed of light it's C. Similarly, for electron charge, this is E, and mass of electron is me, and so on. These are quite useful. Otherwise you can also add your own value as well, and all these values are constant. I'll also try to add the table in the screen so you can see the constant values which COMSOL has predefined. So that's it, guys. I'm sorry this video is a bit quite long, but I think this conditional statement is not much known to many of the people, so I thought why not make a video. And of course, if you are enjoyed this video, learned something, please do subscribe and share with your friends. Also do check out my courses in the description. I have COMSOL Multiphysics courses in different domains, and you can check my Google Scholar profile. You can drop me a mail if you want to collaborate. That's all. Thanks for watching and have a nice day ahead.